But usually you are given an actual graph and then you just kind of move it. What we need to do is start looking at how the graphs and the equations go together. So if you have a function, now we're talking about these parent functions. These parent functions are going to kind of give birth to all the other functions. And if you want to translate something by shifting it left, so you're not changing the size at all, you're just scooching it over to the left, you need to add on the inside. To shift it right, you subtract on the inside. So if we have something like f of x plus 1, it has gone to the left one. But f of x minus 1 will go to the right one. Now, anything we do that translates something horizontally, anything that's translating left to right, always does kind of the opposite of what you would expect. And the reason it does something opposite of what you expect, if you set x plus 1 equal to 0 and solve for x, you get negative 1. If you set x minus 1 equal to 0, you have now shifted to positive 1. So it does the opposite because algebraically it's on the inside. So it encounters the x's first and does the opposite of what you expect. It's just a thing. So that's what it does, okay? So if you subtract on the inside, it actually moves it right. If you add on the inside, it moves it left. So that's just a rule that you need to know. There's no two ways about it. It's just a rule you need to know. Now, things that change vertically, so if it's changing, going up and down somehow, are much clearer, they're so much clearer. So if we want to translate up or down, if we're shifting up, you add on the outside. If you're shifting down, you subtract on the outside. Now, what do I mean by inside and outside? Well, if we have a function and we add one on the outside, it's going up one. If we have a function, we're subtracting on the outside of the function, it's going to go down one. So it's just some rules that are helpful. About moving and shifting our function. Anything on the inside moves it somehow or changes it left to right. Anything on the outside shifts it or changes it somehow by moving it up or down. So then we just have some examples to look at. Yep. So let's take a look at these examples. The question says, how does the function move from the original parent function? What has been changed? So do you see how this one, we have added a 2 on the inside. So that tells me that because x plus 2 equals 0 at negative 2, that the new vertex of our parabola, so it is a parabola or quadratic that has gone to the left 2 units. Now you don't have to say all of that. You can say left 2 units. That's what the question asked. But I wanted to show you why. Here we have subtracted on the inside. So it's going to be a v because its parent is that absolute value v. and it is going to move to the right 3 units. So all we do, those 3 important points I told you, try to graph it with 3 points accuracy. Those 3 points just pick up and shift to the right 3 units. So we can graph so many things now because all we have to do is take the original and move it. Can anybody tell me what is the parent function called that matches that one? 1 over x. What parent function, what's that called? Anybody remember?
1 over
Reciprocal. So it's on the outside of that function. We have added 1. So it goes up 1. So that reciprocal function goes up 1. And actually what I do for the reciprocal function, you know those little asymptotes that you draw? I take and pick those asymptotes up 1 and then move the points over 1, or up 1. This is a minus 3 on the outside. So on the outside, I've subtracted 3. So it goes down 3. So that cubic function that looks like this, all we're going to do is shift it down 3 units. Every point, just slide it down 3 units. So it's kind of nice. And then the last one, anybody notice? Is there something that happened on the inside? It's both, right? So the inside moves it left 1, because remember, if you add on the inside, it goes left. And the outside is a subtraction. It's going to go down 3. So the inside stuff is the one that's a little funky. You are going to, it's going to feel weird because it's doing the opposite of what you expect, okay? So that is those ones. Now we're going to take and we're going to graph from what we know of the parent functions that we talked about Friday and on your quiz. We're going to take each parent function and we are going to do exactly what we talked about, okay? So let me get you some graph paper. I'll give you a few sheets so that you have it. Now, for the most part, you can sketch these out, just, make your own XY axis.
Can you go backward to the last one?
There's some graphic anyway. Okay. So let's just make a little note. I'm going to make a little note here. You already have them, so you don't have to. We're going to just graph those functions. Okay, so this one went left 2. This one went right 3. This one went up 1. This one went down 3. And this one went left 1 and down 3. Did you get what you needed from that top one portion?
Yeah.
Okay. Okay. So I'm going to make a few little XY axes here. Okay. So for A, what's the parent function for A? Think of our if you want to even pull out your quiz review from Friday, what's it called if you have a second power there? What is the name of that?
Quadratic.
The quadratic, okay. So let's write the word quad. Okay. So normally, my quadratic would look like this. All you got to do is take those 3 important points that I told you about and shift them to the left 2. So this would go to left 2, this would go to left 2, this would go to left 2. You see how each one of these scooched over to the left 2. And then you make your parabola or your quadratic. So that's all it is. That's why you learn the parent, because then all you have to do is go, zoop, jump over to the left 2. Let's do B. What's the parent for B?
Absolute value.
Absolute value. We know absolute value is a V. It looks like that. All we're going to do is take the 3 important points and jump them each to the right 3 units. And then we make our graph. So what's great about this is it allows us to graph things without making a table and plugging in points, and it allows us to accurately and quickly graph. And that's one of my main goals for us this year, that you can walk out of this room, look at a function, graph it quickly. Okay. Now, earlier we said C was the reciprocal. Okay, so I'll put that up there. Reciprocal is one of the hardest ones to graph. Okay, let's put the, let me put my, okay, so that was B. Let me make a graph here. Normally, our reciprocal function goes through those 2 points, has a dotted asymptote along the x and y axis, and then it's a swoop. I'm not going to even put the swoops in because it'll be too confusing. There'll be too much stuff, okay? But those are the main things to think about, okay? Now, it says that we just need to lift everything up 1. So you want to lift this point up 1, this point up 1, lift the asymptote up 1. So now the new graph sits, oh, I'm sorry, that was so ugly. It sits here. Because the original graph was down here. So you can see that the new graph is 1 unit higher. So move the asymptotes and then move those 2 points that are like in the corners of the asymptotes, and then draw your picture. What is the parent function called for D? What is the parent function called for D?
Cubic.
That's a cubic, so let's write that down. Now, normally our cubic hits those points. But now all we're going to do is we are going to shift each of those points down 3 jumps. So just count the middle at 0, 0, down 1, 2, 3. This one here down 1, 2, 3. Down 1, 2, 3. And then make your new cubic. So again, this procedure just allows us to graph very quickly and very nicely. So that was D. What is our parent for E? What is our parent?
Square root.
The square root. Okay, so we know the square root starts at 0, 0, does a swoop to the right. So our original looks like this. Now this time we have to move the points in 2 ways. Now it's very good to follow order of operation. What falls first? It moves left because it's touching the x quicker. So move it left and then down 3. So jump this point here to the left. That's not left. To the left 1 and down 3. Left 1, down 3. Move this point. Left 1, down 3. This is the point 4, 2, because the square root of 4 is 2. Move this point to the left 1 and down 3. Okay? And then make your swoop. Now, what if you were unsure? Well, if we look at where x plus 1 equals 0, that happens at negative 1, so that's the new point. So you could plug in negative 1. You are going to get negative 3. You could plug in 0. You are going to get negative 2. You could plug in 3. You are going to get negative 1. So you can plug in points. There's nothing wrong with that. But being in a college algebra, pre-calc algebra 3 course, our job is to try to get past the little stuff. We know you know how to plug into something and be able to do it quickly. And so that's your goal. Can we do it quickly? Does that make sense how we got those graphs? So base them upon the parent functions. The parent functions are not going anywhere. We will be using them for the rest of the year. So make sure you keep this paper in the quiz review from Friday in your notebooks so you have them, you know, as a guide for yourself, because they're never going to go anywhere and you'll get really quick at them. Does it make sense how we did those?
Yep.
You can always plug in points if you're a little unsure. Your homework, you have 10 graphs. Tell me what is the parent function and describe what the transformation is. It's going left, it's going right 2 units, it's going up 2 units. So tell me the parent and also the transformation, and then graph them, okay? And so you have 10 of them. So there you go.